Welcome to another Benedict Research Labs video. Today we're going to learn how to execute a Gaussian job using a WebMO interface. This is the URL of the WebMO installation at the CCR at Buffalo, University of Buffalo. Go to this URL, enter your UBID with your CCR password, and click Login. First screen you're going to come to is your WebMO Job Manager. This basically is the history of all the jobs you've run, some details and status, and if you'd like to then look at your jobs, you have the option of either clicking on a name or this little magnifying glass. All right, today we're going to start a new job. We click New Job, and here we go. This is where the screen where you'll build your molecule. You can import a molecule from a crystal structure. This would be a CIF file or an XYZ file. A few other options as well. Or you can build your molecule. The default atom is carbon. We're going to build water, so we'll just start by choosing 3 atoms. Here's oxygen, and now choose hydrogen, and we have our 2 hydrogen atoms. There's water. These blue arrows move you through the WebMO interface. All right, we want to run a Gaussian job, and we're going to use my nodes, the JBB6 nodes. Okay. The next screen is where we configure our basic job options for a Gaussian calculation. Here we have the name. You can change this to pretty much anything you want. The type of calculation that you're going to do, molecular energy, geometry, so on and so forth. We'll just set up a quick molecular energy. Here's the level of theory. This will be a DFT-B3 lip calculation. This is where you choose your basis set. You have a few to choose from here. You can enter in another basis set. We'll just choose this rather ordinary 631G basis set. Set the charge, set the multiplicity of the electronic ground state. We're going to move now to the Advanced tab. Pretty standard stuff here if you're going to be running a bunch of jobs back to back. So for example, the first job is this energy calculation followed by a an MO calculation followed by a UV viz. You're going to want to save checkpoint files, and if this is a second or third in a cycle, you're going to want to load a checkpoint file from a previously run job. All right. A few other self-explanatory options here. The only other thing to choose in this case is 12. The nodes we currently have all have the 4 nodes we have all have 12 processors per node, so we enter 12 here. And we're now going to move to the Preview tab. When we click the Generate button, what this will do is generate a Gaussian input file based on the options that we've specified in these 2 previous tabs. So you can see the number of processors is 12. Our output file, to save the output file, shows up here, the checkpoint file. And if you want to configure any other add-on features, you would do so on this line. The one thing you'll want to do for just about any job you run is to specify the amount of memory that you'll use in the calculation. These nodes all have 48 gigabytes of memory. We're going to specify 45. This leaves 1 to 2 gigabytes available for the operating system. Okay, this is now ready to go. To submit a job, we click this arrow. It's basically going to ask us if we want to submit it. Yes, we do. And this will take us now back to the Job Manager screen. This is the job that was just submitted. You can see the yellow, the job is queued up. If we hit refresh, the job is still queued. And at some point, the job will start to run. It should take just a few seconds here. And sometimes for a very fast job like water, oh, there we go. The job is now running. It's been running for 1 second, and if we refresh again, it'll probably be done, and in fact it is. So there you have it. That is how you run a Gaussian job using the WebMO interface. Thank you very much for watching.